Hannah, and welcome to LEDucation. We appreciate you starting this early in the morning. Just a few housekeeping things to go through this morning. Thank you, I need this. First off, at the end of the program, we will be having a docent tour if anybody is interested in remaining behind. We will have a couple groups that will be, a couple leaders of the group from the lighting industry that will be taking small groups around to individual lighting manufacturers that will be explaining their products, and if you have any questions about LED lighting or anything related to the lighting field, they will be answering those questions at that time. I'll be returning at the end of the question and answer period to break everybody into small groups, so the docents group will be starting at that time, number one. Number two, if you are a architect and you're looking for AIA credit at the end of the program, there will be a sign-in sheet at the outside of the room. Please sign in, give us your AIA number, and we will be able to register you for your credit. If you're self-reporting, if you are scanned at the door, then you will be sent a certificate from the DLF, and you will be able to do your self-reporting at that time. Number three, if you go online, LEDucation.org, please give us an evaluation of the speakers and LEDucation, how you like it. We do appreciate any input you have, positive and negative in that. It helps improve the programs as we go along with LEDucation. Number four, there was a four, wasn't there? There was a number four. There was a number four. They keep adding them everything. Number four, any handouts and everything, they are available online, and also give us about 2 to 3 weeks. All of the programs in PowerPoint form will be available online. That was number four. They will be available online on LEDucation.org, and all the programs and all the presentations that we're giving through LEDucation will be available. Give them 2 to 3 weeks, and they will be available. Okay. Next, we will begin. John Catamaris is a registered architect and NCIDQ certified interior designer with 30-plus years of experience as a practitioner and 15-plus years of experience as an educator. At New York School of Interior Design, he is a program director of both the Master of Professional Studies in Interior Lighting Design and the Institute of Continuing and Professional Studies. He holds an MFA in Architectural Lighting Design from Parsons School of Design and a BS in Architectural Technology from New York Interior Design, NYIT. Sorry. That's okay. There you go, John. Take it away. Let me just move this here for the next one.
Good morning. How many RAs do we have here this morning? We've got a couple. My sympathies. Little story, a couple of months ago my phone rang, and I was told that, well, it would be a great idea to have an educator delivering a seminar at this year's LEDucation 11. My reply was, that's great. Who would you have in mind? And they said, well, you. I said, oh, okay, all right, I'll give that a shot. What's the topic? And they said, well, that's your choice. Okay, what about the time slot? I said, 8:30 in the morning on the second day. I said, this just keeps getting better. So I thought to myself, given those parameters, maybe I should take a step back and pick a topic that I experience, but it's relatively hard to find any documented information on, and that's visual comfort, specifically as it relates to discomfort glare. We experience it, very hard to benchmark it. It's like the weather, everyone speaks about it, but very hard to take action against it. So that was my journey. So today I'm going to share that journey with you as far as the information I was able to unearth, in some cases collate, in some cases left unresolved, because there's still a lot of open questions. So it's a big topic, but more or less it's also an unresolved topic. As far as education, this seminar specifically is not intended to provide you with a silver bullet. It is intended, hopefully, to trigger some thinking, perhaps unsettle some minds, widen some horizons, broaden the bigger picture. So if I'm successful, and I include myself in this objective, we will all leave here this morning a little unsettled, perhaps a little wider. Sorry, ladies. Unsettled, thinking, maybe bringing some questions into some of the exhibitors out there and see how they sort of address this discomfort glare issue. And I've tried yesterday subtly to ask the question, and I met with varying amounts of success. So let's begin this journey. We're going to hold all questions until the end. That's pretty much standard procedure. I'm up against a hard break at 9:30, I believe. There's a docent tour, so I've got limited time. I'll try to make effective use of this time. I'm going to spend varying amounts of time on a slide-by-slide basis. Hopefully, time management is always tricky with things like this. 6 separate dimensions we'll be touching upon this morning. They're all interrelated, but at the same time, they're separate. We've got vision geometry, angle, central vision, peripheral vision, how that factors into the discussion, the glare gamut, the glare range, visual comfort limit, which is a little bit different than visual comfort probability. The latter, number 4, is a rating system. The former, number 3, is sort of generally accepted maximum brightness values given certain angles, certain viewing angles. Unified glare rating is another metric. And then luminance data, brightness. Luminance is the metric as far as brightness. Typically, candela per square meter is used, sometimes candela per square foot, sometimes foot Lampert. A lot of little metrics floating out there. To guarantee I'm not going to run out of time and cut the presentation short, I'm starting with the last slide. This is like an insurance policy. This is the end of the journey. The rest of the presentation gives you the method on how I arrived at this destination. The mindset here, the philosophy, the approach is open for interpretation. It's even open for you to fold into your own thought process. Conceivably, each one of you can leave here, well, not this morning, but in the near future, with your own checklist, your own benchmarking. I mean, that's the idea. So to give you an overview of what this end result is, if I can get this thing fired up here, comparable luminance, brightness, measured brightness. The y-axis here is in terms of candelas per square meter. The numbers across the bottom along the x-axis are the case study, the item numbers. These, let's call these viewing angles at industry-accepted increments from 45 to 85 degrees. I've got mixed feelings about the energy code, and I'm not going to discuss that in this meeting. I'll gladly stay back here later and render my subjective opinion about it, but it has shaped a thought process, without questions, made our jobs, in some cases, much more complex. As far as what we've got here, we've got a range of technologies from legacy technology to solid-state technology. All 2x2s, keeping the format relatively consistent. There we've got a 2x2 prismatic acrylic. Below is the familiar 9-cell, I think it's a 9-cell, deep cell parabolic. Again, fluorescent fired. Center barrel, one version fluorescent. The next iteration is LED. And then we've got the flat panel. The exit lumens, the new lumen on the block, along with 8 or 9 other lumens, is the amount of light leaving each one of those devices in all directions. It's averaged across perpendicular, parallel, and at 45 degrees. So there was a lot of math, sort of gymnastics going on to get to this end result. Efficiency, the amount of light leaving the device compared to the amount of light produced by the engine. And now I'm using engine as a sort of a term that unites all different types of lighting technologies. So the efficiencies, the luminaire efficiency ratings vary. It's nature, and I experience this daily. It's natural to look for patterns. You're not going to find any. If you're trying to compare efficiency to exit lumens, to glare, there are no patterns. These are all different dots floating around out there, and as designers, as specifiers, we need to try to connect those dots, and that's always been the challenge in this craft, lighting specifically. I forgot, those red horizontal bars. Those are generally accepted maximum brightness values given those viewing angles. And what you can see is I've got these products color-coded. Some products aren't doing a very good job at coming close to those maximum brightness values. As a matter of fact, as the angles increase, more product does a less and less effective job as far as managing glare, hitting below those benchmark brightness values at critical viewing angles. So I'm not going to say there's a bit of a disconnect, but there's a bit of a disconnect between visual comfort and the performance of these luminaires, taking into account visual angle. And this, to some degree, may be the culprit behind that. Last slide. That was the second to the last. This is the last slide. Depth. This little icon here is for depth, and it's synonymous with understanding. And this is where it gets even more challenging. We're all familiar with what we've got to hit as far as productivity, fees, demanding clients, time schedule. The amount of information we're exposed to is almost beyond our ability to even understand it, keep up with it. So we're running in place. That runs contrary to creating a culture of understanding, so we know we have a deep understanding as far as what we're doing, a deeper awareness. So many times we're just doing things out of habit, out of rote, out of pressure, without digging into that next level. So we're skating, in many cases, just as a matter of survival, but not walking away with a much deeper understanding. Reconciliation, rethinking things, what's going on? Our language has been moved around. It's always under revision. But as an architect, I sort of was, well, I'm fascinated by the fact for the first time ever, I've had to jump this division with language to take into account competing geometries. Many times with LEDs, they function as a luminous body. They function as two-dimensional objects in reality. There's a length, there's a width, but there's no appreciable depth. Conventional light bulbs are real three-dimensional items, conventional lamps. But originally, lumen, by definition, luminous flux, is the amount of light given off in all directions. Well, in all directions, that's interesting, but if you were to look at a light bulb, there are lumens that you are not experiencing, lumens that are not contributing to that visual experience. This is not true with, let's call it, two-dimension LED technology. So lumen now begins to have a minor sort of a dialect onto itself as far as what does it really mean with this coexistence of two-dimensional and three-dimensional reality living side by side. In some cases, being brought to market. This geometry here, this linear geometry, is very different on the mathematics side than a fluorescent tube, even though you may think of a tube as linear. Let me explain this in further detail. If you look at a light bulb such as this globe light bulb, looking right at it, you would depict it as a circle. From a luminous perspective, you can think about it producing light as a hemisphere. On the box, the lumens rating is on a full sphere. But the light that's traveling backwards, in theory, behind the light bulb, you don't really experience. The same is true with a fluorescent tube. If you look at a fluorescent tube dead on, it's a rectangle. If you take a step back and realizing, well, it's also curving towards you, well, that's a sort of a hemi-cylinder. But the lumens rating as if it were a full cylinder. This is not the same with devices like this. There really is only a length and a width, and those lumens are all coming right at you. There's nothing, for the most part, going out the back. This is fundamental to the idea of the difference between delivered lumens and lamp lumens. And this is where not understanding, not grasping, not appreciating that subtle difference could result in an installation that's producing much more glare than you originally anticipated. For example, if I was to translate now many times LED manufacturers' products, they've got a variety of light outputs, power, per linear foot, lumens, per linear, all these kind of things kind of tie in together. And color is not part of our discussion. Color is another dimension that also, in some cases, redefines lumens, how we experience it. But if we were to reconcile this, take an LED vanity bar at a variety of light outputs, well, that's the light traveling towards us. That equates roughly to anywhere, if we would convert that now to the traditional idea of a lumens with a three-dimensional bulb, that light bar translates to anywhere to 2 to 4 times brighter than a 100-watt light bulb. Or was it 60%? To 120% of an unshielded 32-watt fluorescent. That's a fair amount of light. The other dimension here, the other concept, the other component is I take these linear devices and I flank maybe an 18-inch wide mirror. Now I've got this light as objects trespassing now into my central field of vision. I'm looking at myself in the mirror, but those bars are right there delivering light more or less right at me. Well, put on a dimmer. Yeah, we know that. But that doesn't foster, promote a deeper understanding of what's going on here. What else plays into these equations? Well, things like this, a dark background, which may make for a very compelling graphic or an optic. But now superimpose that. You're standing at the mirror, looking into the mirror. You've got these luminous bodies alongside. You've got a dark surround beyond that. Now you're compounding this luminous experience. In the case where you've got a situation like this, something like that, and you've got a high luster surface adjacent to it, now you've got reflected luminance coming back at you at the same time. In a room where that's the only source of light, now you've got another problem. Because to efficiently, I should say challenge, I'm sorry, problem is not PC, challenge, excuse me. You've got another challenge, is that trying to get the room overall effectively illuminated, you may be triggering now a disproportionate amount of brightness out of those devices that are lighting the room. Out of these, and these are some of my favorite books. One is Blink, and the other is A Field Guide to Lies, I think is the other book. But the bottom quote, how you get into trouble, right? Mark Twain, that's it. I mean, that's for all of us. We've got to, it's not what we don't know, right? It's what we think we know. That's what can kill us. So we've got to be careful about things. And that's the difference between skating and going deeper. Of course, when you're going deep, there's no guarantee you're going to be able to get back up very quickly. And sometimes you don't even know where you're going to wind up. Everything lights up. to the point that I used to know what a light bulb meant. I don't even know what a light bulb is anymore, or a lamp. If we expand the definition of a lamp or a light bulb, then all these are light bulbs in one way or another. They're all producing light. So as a civilization, we're looking right into sources of light. Is there a long-term effect here as far as desensitizing us to the awareness of glare? I don't know, maybe. Maybe that's an esoteric question. I'm not quite sure. It's like if everyone is shouting, can you really hear anybody anymore? You see the technology out there. We can put light everywhere. It doesn't mean we have to put light everywhere, really. Competing opinions about light and how we experience it, and how glare factors into the equation. Toxic light. I was not familiar with that term until I began to prepare this presentation. Some statistics can lead us astray. The Vision Council report reveals a third of adults spend more than 9 hours every day on digital devices. This is also the path to understanding. What does that even mean? If I'm speaking on the phone and at a computer, does that count as 2 devices? And if it does that skew the numbers here? Or am I to assume, because it says the Vision Council, it's only digital technology that I'm looking at? I don't know. And this is sort of the challenges, the questions I was always coming across as I was digging into this topic of discomfort glare. What do these metrics really mean? Are they even relevant? Do they make any sense? How do we apply them without being misled? Eyes are not designed to look directly at light. They are designed to see with light. Okay, well, now what does that mean? You can see light based on looking directly at the source. That's generated brightness, or generated luminance, what I call it. You see my face based on reflected brightness or reflected luminance. You'll see these glowing here. You can argue that's based on transmitted luminance. So we're always looking at light. What does this mean? Don't know that either. That's the part of diving in deeper and deeper. It leaves you with more questions than it does answers. Unified glare rating, visual comfort probability. 2 metrics for benchmarking the performance of products. Typically, unified glare rating, UGRs, start at 10 and end at 30. Is that right? I think that's what it is, 10 to 30. And not quite sure, the metrics are odd. They're in 3 levels of increments. So it's 10, 13, 16, 19. Not quite sure what the history is there. The UGR end result is based off of a mathematical calculation. Maybe that's why you've got those strange bumps, those 3-part bumps in there. And that mathematical combination conforms to a report produced several years ago. So everything neatly falls into place. It's just not easy to come across the UGR rating of a given luminaire. Visual comfort probability is very different, and I think VCP pre-existed UGR. And VCP is on a percentage rating, and it has to do with how many people do not experience discomfort. So there are 2 different ratings systems. So if a product has a VCP of 90, what it's saying is that 90% of the occupants or the observers will not experience discomfort glare. And they can be cross-referenced. UGR numbers in that lower graph here, and there's the VCP equivalent. So this means not experiencing discomfort. So this is a better product, or better rating, I should say, than this is. And as the UGR goes up, there are more possibilities of an observer experiencing glare based on how that entire parameter has been established. And that's also very granular as far as the structure behind these ratings systems. Has anyone heard of either one of these two, UGR or VCP? Good. How often do you come across them as far as being generally accessible or easily published? Often? All the time. Good. That's good. VCP and UGR ratings are validated more with devices that are uniformly luminous. They've got a uniform glowing sort of aesthetic. As soon as you cross into points or pixels, VCP and UGR, to some degree, they lose their validation. Now, there's another gray area in here, too. Because of LED technology, you don't need to have all these individual pixels happening to fall outside that original frame of reference for UGR and VCP. You can have a very compact luminous body in a much larger physical enclosure, and that also really does not fall in line with uniform luminous body. It's more a point glow. So there's a lot of straddling on what the definition as a practical matter is with a uniform luminous body. And LED seems to be bouncing around there. It can be homogeneous, it can be uniform, like the flat panel, or you can have varying amounts of pixels, in which case that would fall out of the traditional UGR or VCP rating system. Going back to the geometry of vision, I love these graphs and diagrams. They're very impressive. I own a pair of eyes. Had them most of my life. Performance kind of up and down. Had good days, had bad days. When I look around the room, I don't see these concentric rings. When I stare at something, nothing shoots out of my eyes. I can see my central vision. It's all sort of organic. Everything blends. So as the owner of two eyes, my world looks different than what these diagrams present. However, to try to circle back as far as what does viewing angles, what do they mean, I want to take some time looking at this slide. This was very early experiments regarding brightness and glare and how to adjust brightnesses, and is the object of the same brightness, does it appear as the same brightness as it changes its vertical placement in the visual field? And at the risk of oversimplifying those experiments, which date back to 1925 and various iterations since then, generally speaking, as the source moves up in the visual field, you can increase its brightness and experience the same level of discomfort. So there is a dynamic that happens there. This is keeping your eyes straight and horizontally. This is a little bit more as a practical matter. The viewing angles that appeared on the early slide relates to this viewing angle up here. It's the angle up from vertical. The observer is in the room looking straight. This is that viewing angle. Sometimes it's called the incidence angle. There's a lot of titles out there floating around. Just understand the graphic here. So if I place a device here, a luminaire there, with the person looking straight, there's your central cone of vision. That is a viewing angle. I take the same device and put it further back into the room, and you keep looking straight, that viewing angle increases. But as this viewing angle increases, this angle decreases. So you've got to keep, no pun intended, you've got to keep your eye on two angles. It's this angle and it's that angle. What happens as this viewing angle increases and this right now untitled angle decreases, those luminous bodies drop closer and closer into your central field of vision. So more often than not, it's not the luminaires that are close to you that you'll be experiencing glare from. It's the ones further into the room. That's why that original graphic showed those horizontal red lines were decreasing in acceptable levels of brightness as that viewing angle increased. So this is almost a little bit counterintuitive. You would think the ones closer to you are more important from a glare perspective, but taking into account vision geometry, that may not be the case. It's the one further away. Not only because it's because of that angle, but you tend to have more luminaires in your field of vision further away than you do closest to you. As far as the bath bar, the same thing would apply, only it's now, you've got to take this diagram and now turn it sideways. Now it's a lateral. One of the biggest problems with glare is that it's highly subjective. And these are the traditional definitions and what affects them. The clarity of media of the eye, which can vary from one eye to the other on a given day. So there's no constant there. The state of adaptation of the eye, well, that depends on what you're looking at. I know with my pair, I don't know if it's the same with everyone here, my eyes self-adapt. I really can't control what they're doing. They just do it on their own. Then you've got background brightnesses as well. There's a lot of moving parts here that makes discomfort glare, dealing with discomfort glare, very, very complex. In some cases, go well beyond any kind of posted metric. Sparkle, if you like it, it's sparkle. If you don't like it, it's glare. That's in essence, that's the short definition. Direct, indirect disability, discomfort, UGR, VCP ratings are focused on discomfort glare. That's the essence, that's the epicenter of their calculus. Glare which produces discomfort without necessarily interfering with visual performance. I don't know if I would accept that as really the way to go as far as setting the bar. It's a bar, it's a benchmark. It's compliance, minimum standard. As far as these A, B, C, and D, I think maybe we can agree that more often than not, B and C is probably a good indication of glare, of discomfort. Whether it's discomfort or disability, well, that depends, but I think we could agree on that. A, I don't know. Glare, sparkle, a lot of variables in there. As far as D, depends on the price tag and who's buying the jewel. Generally accepted, whatever that means, brightness levels in terms of foot candles, and you can see here, this again reinforces that earlier statement I made, that further away the luminaire is, because of all this geometry involved here, the brightness levels drop. The recommended brightness levels drop. Luminance is a measure of brightness. The scissors curve, very early graphic, tried to put a ceiling, a limit on recommended brightness. These diagrams sort of feed off one another. The scissors curve, however, VCP in particular, had very specific criteria originally when it was created. Initial average horizontal of 100-foot candle. This is kind of like the lab, this is the model that was set up in creating these metrics. Room reflectances, mounting heights, room dimensions, where the observer is in the room, what the observer is looking at, in which direction. Look at number 7. I don't know how to understand number 7. It's a cutoff of 53 degrees. I'm not quite sure how to interpret that. If I'm interpreting it as that angle up from vertical, well, 53 degrees would translate to luminaires closest to us, not the ones further away. So I don't know where this figures into the calculus. Is this working towards me, helping me or hurting me as far as understanding this glare metric? Scissors curve has a long history, 1956. It was never intended that this curve continue indefinitely. That's funny, I haven't seen one since. Not that I saw the one in 1956, but maybe there are more recent iterations out there. Unable to come across any of them, at least easily as far as research. I do not get Scissors Curve Monthly magazine, so I don't know what the latest curve is here, but I'll try to find it. Again, we've seen literature like this. That's relatively easy to come by from the manufacturers, but it's plugging into the situation that makes it challenging. I'm keeping an eye on the time here, so I'm going to speed it up just a little bit. So it's time for questions. This is the foundation on how I created that first graph. Sometimes in foot Lampert, sometimes in candelas per square meter. I had to reconcile the math, create these benchmarks, interpret it off the graph, and create this whole series of points to hit. There's the mathematical conversion right there, keeping a check and balances going, make sure I don't stray off course. And that's what set this benchmark up. And this is what I'm talking about as far as anyone here can create this kind of cheat sheet based on how you apply, how you work with light. From my perspective, because light is intangible, because there are so many things, seems like in a constant state of change, just on the technology side, forget the client and the application side. It gets very complex. It's helpful for me as an architect, as a practitioner, and to some degree as an educator, to set up benchmarks that I understand, so I keep things in context, rather than trying to connect, to make sense out of a lot of information from different sources, in some cases competing sources as well. I need to be able to wrap my head around it. Just like staring at that damn light bulb, saying this is a sphere. Lumens is 3D, but I'm looking at the light bulb. It's not translating right. It's just that kind of hands-on approach is what I typically embrace. Shielding. Shielding used to have a massive scale to it because, well, the lighting devices themselves had a large scale. I mean, you could hold on to a lamp. You could hold on to those lovely old magnetic ballasts. So everything was kind of scaled up appropriately. And shielding, for the most part, was designed to block view of the lamps, direct view, primarily in the lower viewing angles, and contribute to reduction in brightness at the higher viewing angles. I used to have catalogs of manufacturers of shielding media. Many times, shielding and luminaire efficiency run contrary to each other. The better the more effective you are at reducing the glare, the more you're cutting down on efficiency. So you're trading off now quality versus quantity. Also have to keep in mind distribution patterns as well. If the shielding is cutting down on high angle glare, that's going to impact your spacing criteria, which means you're going to need more luminaires in the same space. So all these things now get dumped into the blender, you hit puree, and you pour out ultimately your best reconciled design solution. It's a juggling act without question. But I can say, again, more often than not, and this sounds almost contradictory, the issue of glare tends to take a sort of back seat right now, unfortunately. I've got other more obvious criteria that in some cases I'm compelled to comply with. More of the same as far as VCP compared to luminaire efficiency. More often than not, as the VCP goes up, the efficiency drops. Again, trading off quality for quantity is not unique to lighting design. It's just life, generally speaking. However, we've got a shift in scale now. You used to have large light bulbs. We used to have mixing chambers in recessed luminaires, surface-mounted luminaires. There's no more of this massive dimensionality. Everything is being compressed thinner and thinner and thinner. Shielding, in a traditional sense, shielding media now has now given way to this micro technology. And in some applications, the idea of the micro technology, this thin film technology, is in essence to do the same thing. It's to prevent glare, discomfort glare at higher viewing angles. At higher viewing angles. But once again, by doing this, see the graphic here, it may impact your spacing criteria. You may need more luminaires. More luminaires could translate into more energy consumption, could translate into greater watts per square foot. But we've got a cap on that in many applications. Apples and oranges. I sort of alluded to that, what I just said in my previous statement. If you bite quickly at a better UGR rating, you've got to take a step back and make sure, wait a minute, if manufacturer A or calculation A produces one UGR rating, and this is better than manufacturer B or calculation B, well, are you comparing distribution patterns the same way? Exit lumens the same way? I mean, how far do you want to take this? The price of the actual product? So again, once again, you can't write a song with a single note. It's pulling a lot of this information together and reconciling it and making the appropriate decision given all those circumstances. All right? This is where it gets a little bit faster because there's no really new ground here. I just wanted to take a step back for a moment and look at our legacy. This is the device. The acrylic prismatic recessed fluorescent is really what the entire VCP calculus was formulated on. This was sort of understood as being a luminous plane of light, and then we've got these gigantic lamps in there, and we've got this large mixing chamber. And that is how the VCP equivalent was set up. And then pulling out luminance data is relatively easy to do. It used to be published relatively easily, in conspicuous places. And then we've got coefficient of utilization, which is sort of like the gold standard, in my opinion, as far as the effectiveness of a luminaire given a set of circumstances. And this is nothing here but a reconciliation, and there are those angles. The next player, a little bit outside that VCP, was a deep cell parabolic. What pushed this into the marketplace were the old video display terminals, trying to light with low glare on the screen on those old fisheye glass screen computers. If you recall what the downside to the parabolic luminaire is that the luminaires in the greater distance appeared to go dark at the ceiling line. So the room was lit, you had a dark ceiling line, dark luminaires, which was for the most part dealing with glare, but the subjective impression of the space wasn't very good. It began to be like a cave. Also, as a sort of casualty of war, that clipping of the light made things very difficult and provided more often than not extreme cutoffs near vertical surfaces. So the overall aesthetic wasn't working very well. It did a great job as far as cutting down on glare, but subjectively it did not translate, all things considered, to a successful lighting solution. The next step was the direct-indirect, for lack of a better term. We took the lamp, crammed it, well, in the case of a center barrel, put it right into that center barrel. This was a natural home for the high lumen, the long biax lamps. The end result, and this mixing chamber was left open, there was nothing there anymore, so the lamp was only shielded here. This fixture is highly directional, meaning if I was to run a VCP calculation that was looking perpendicular to the barrel, I'd have one result. If I turned 90 degrees, I had a completely different result. And 45 was somewhere in the middle. But because now we've got these high lumen biacs stuffed into this center barrel, they didn't do a very good job of addressing glare further into the room or as the visual angle increased. There was a real bright part there. Much more efficient. The environment was much more luminous, but much greater incidences of glare. Take into account all the geometries. And that's the sum total just of those first three legacy technologies. This is where delivered lumens, this circles back to what I was saying earlier with staring at the light bulb or holding a light bulb, holding a fluorescent tube, and understanding where these metrics came from. This light is largely, it appears on the lamp literature on the package, but rarely leaves the luminaire. So it's energy that's just gone, it's light that's just gone. This is the light, for the most part, that contributes to the visual experience. So all of this back here needs to be discounted. So in moving from traditional sources to LED sources, which much more precise optics, you've got to be careful you understand what the new lumen means compared to the old lumen. The visual experience could be very different than what you expected. Well, thin as in, what can I say? That's vintage image of Twiggy. I don't know why I even did that. It seemed like a good idea at the time. What can I say? Flat panels, much more efficient. Some flat panels have that microfilm technology. Some don't. Need to keep that in mind as far as how they appear as you go further and further into the room, and how the ceiling height can affect the appearance of these panels, if they're contributing to glare or not. Our purple friend here didn't hold up very well as far as exceeding the recommended benchmarks, if the recommended benchmarks are even relevant. That's the other question. If we hang our hat on standards and guidelines, I feel comfortable that I've got a better understanding of the origin, the method on how those standards and guidelines were arrived at. Personally, I don't think they're far off, personally. And the center barrel, one of the more efficient ones, again, based on those internal optics, but that center barrel is going to be bright. And the possibility of experiencing discomfort glare at high angles is there, could be there. Now this slide looks familiar. This was our lead-in slide. It's the end slide here. As with most standards, minimum requirements are laid down. Standard compliant lighting is no guarantee in itself for good lighting. It's hard to read this kind of cockamamie angle. And I don't want to read off of this. For this application know-how, these are the U's, these are the understandings. Application know-how, product know-how, and situation know-how. Those are the understandings. You have to understand the product, understand the application, and understand the situation. You take those, you combine them with your own custom-designed glare cheat sheet, and you're moving forward as far as doing your best to contribute to the reduction of discomfort glare in the visual environment. Why should we even do that? Because discomfort glare degrades the quality of our visual environment. It is folded into, it's a latent component of health, safety, and welfare, in my opinion. Where comfort tends to have a wide range, discomfort tends to have these sort of cutoffs, these benchmarks. So working towards that, engaging in direct dialogue with manufacturers, trying to understand, well, where do I find this information on your product sheet? How do we get this dialogue moving forward? I think that's up to all of us. I know from my standpoint, when I look at a product, the first thing and if you see me out there, you'll see me doing these kind of weird things. I start changing my height, and I start doing this. Try to get a sense of how this thing, how's it going to look from different angles. So I'm making an informed decision. Because the answers I'm looking for, sometimes they're just hard to find on generally published documents, those upfront documents. We've concluded at 9:25. That's not so bad. I had to skip around a little bit. Sorry if I had to gloss over some of these slides, but it's the nature of these live presentations. Are there any questions? Well, either did a very good job or a very bad job. Yes, there's a question.
Yeah, where would you, based on having walked around the show so far, where would you go to look for some, if you will, comfortable luminaries? What have you seen?
What am I seeing? I'm seeing. I know what I'm hearing. I'm hearing the same, more or less the same narrative. Lumens per watt, high efficacy, high efficiency. That's what I'm hearing. That's what I'm seeing. I don't want to go into too much detail, but I did approach UGR and VCP specifically, and the 3 different occasions yesterday, and the answer was, we'll have to get an engineer. We'll get back to you with an engineer on that. I said, okay, that's fair. I mean, that's fair, yeah.
If you want to see a luminaire designed to UGR 19, go to the typical standard. That's the design of UGR 19.
Yes.
You can make your own assessment.
Yes. Yes. I can't say things like that up here, but you can. So, yes, absolutely.
Where did the 1923 come from?
No-
What's the source of that information?
The 1923.
19 and 23. So anything above 23 is bad, and anything below 19 is good.
Oh yeah, the UGR ratings. They tie there's a formula that they've tied into matching up to a CIE document that has this mathematical representation as far as the answer to the equation. If it hits in there, that's how it was qualified. It's all mathematical representation for the most part.
So your average reflects 750-20 on the average room.
Right.
That's how you get UGR 19 or lower. 22 is bad. 22 is actually good. 19 or lower is actually deemed for the workload. But there is no good or bad. It's really your application area, your threshold that you want to work with.
Yeah, it's a guideline. It's really a guideline. Look, this is an oversimplification, but experiencing light is not unlike eating a meal. You can count the calories. What is that really telling you, though? I mean, it's telling you something. It's not telling you everything. Doesn't tell you if it tastes good. That's exactly right. And because I like it, you may not like it. It's perception. It's subjective. And as designers, that's what we should really be sensitive to. Not biting down hard and fast on these numbers, on the numbers game. Yes?
So one of the things you seem to be saying is not to, is to creating some screening, which is undefined at the moment as we're moving forward into LED. But you really want to be conscious that the screening performed well in the past, and maybe it's the way forward with the flat panels to get a better comfort level.
Yes, we're all coming from different perspectives in the same industry. We all need to do our due diligence and create, in essence, our own model. And if it departs from UGR or VCP or interpreted differently, then we need to jump into it. I think I'm calling for self-governance and some self-policing. I mean, that's what I'm calling for. What's wrong with that? I think that's the way to go. That's the way to, someone that's focused on, again, no pun, exterior lighting. That's a very different package in some ways, right? But it's those people, those professionals, they've got to set that bar, find out where that bar should be, and pursue it accordingly. It's up to us. We're the damn specifiers. We should be driving the industry, really, in a perfect world. Not watts per square foot. But what can I say? Hey, that's not like Howard Rourke. Yeah. Any other questions? I've got opinions about the energy code. Any other questions? I think the docent tour, we're set to go. Thank you very much. Thank you.